Today, I'm about to explore one of the most extraordinary natural wonders of the world. Right now, I'm in northern Canada, and I've come all the way here just to watch the sky. I know, pretty crazy, right? I could have just done that from my bedroom window. But the sky up north is very different. How? See for yourself. The sky's on fire! Or is that some strange form of lightning? No, it's neither. What you see here is the Aurora Borealis, the northern lights. The same phenomenon occurs in the southern hemisphere, called the Aurora Australis, the southern lights. Not your everyday night sky, is it? Auroras are bright light displays in the sky that occur in the Arctic and Antarctic regions of Earth. They are continuous and can be clearly seen at evenings and nights, especially during the winter. Aurora Borealis means dawn of the north. The name Aurora comes from the Roman goddess of dawn who would fly across the sky every morning to announce the arrival of the sun. There are many misconceptions as to how auroras form. Some common myths are that they are caused by sunlight reflecting off the polar ice caps or moonlight reflecting off ice crystals in the atmosphere. Auroras are actually the result of collisions between charged particles from the sun and gaseous particles in Earth's atmosphere. Out in space, charged particles such as protons and electrons are shot out from the sun's gravity and flow towards Earth. These streams of charged particles is called the solar wind. When this solar wind reaches Earth, the particles collide with nitrogen and oxygen atoms in the atmosphere. These collisions energize the gas atoms, which then release the energy in the form of light, and this is how we see an aurora. The constant collisions of the particles cause the auroras to appear in various shapes and colors, rippling and flowing like an ocean in the sky. Beautiful, aren't they? Sort of like works of art, paintings, the artists, electricity, and magnetism. Now, to understand the roles of electricity and magnetism in the creation of auroras, we need to recall the structure and nature of the atom. Everything on Earth is made up of atoms, which contain electrons, protons, and neutrons. When an atom loses or gains an electron, it attains a positive or negative charge. According to the law of electric charges, like charges repel and unlike charges attract. This force of attraction and repulsion between charges is called the electric force. All charges produce what is called an electric field, a surrounding region in which an electric force is exerted on another charge. So, if you have a charged object, another charged object entering its electric field will experience a force of either attraction or repulsion to it. Planet Earth has its own electric field. Charged particles from the sun collide with particles in the upper atmosphere, stripping them of electrons. This region, called the ionosphere, is therefore positively charged. In contrast, Earth's surface is more negatively charged. Both areas tend to stay that way, and so a permanent electric field exists in the atmosphere. Now, what exactly does this have to do with auroras? Well, both Earth and the solar particles have electric fields. So when solar wind hits the atmosphere, the electric fields of the charged particles interact with Earth's electric field. Some particles are attracted while others are repelled. And this attraction, repulsion, all this motion causes collisions. And as the particles bombard with gaseous atoms in the atmosphere, light energy is released, producing an aurora. Like electricity, Magnetism also plays a big role in causing the atmospheric collisions. Planet Earth has magnetic properties. It acts like a magnet, and, like all magnets, Earth has a north magnetic pole and a south magnetic pole. These magnetic poles are different from Earth's geographic north and south poles, the poles through which its axis of rotation passes. So, Earth is surrounded by a magnetic field that's strongest at the poles and expands far into space. Magnetic field lines spread out from the north magnetic pole and meet again down at the south. Scientists suggest that Earth's magnetic field originates from deep within its center and is likely the result of electric currents in its liquid metal core. Earth's liquid outer core is comprised of extremely hot molten metal. The liquid metal circulates through the process of convection, generating electric currents. And, just as the principle of electromagnetism states, these circulating electric currents create a magnetic field around Earth. And this magnetic field directs the motion of charged particles from space. When solar wind enters Earth's magnetic field, charged particles near the equator are deflected, while those near the poles become trapped and travel along the magnetic field lines in spiral paths. So the particles spiral down the field lines to Earth's magnetic poles where they accumulate. And their buildup results in more and more collisions with atmospheric atoms. And as mentioned before, the collisions release light energy, causing the glow of the northern and southern lights. And this part of the atmosphere, where charged particles interact with the magnetic field, is called the magnetosphere. Since Earth's magnetic field is strongest at the poles, auroras occur at the poles. So now we know that both electricity and magnetism play a huge role in the bombardment of particles that causes auroras. Earth's electric and magnetic fields affect the behavior of charged particles in outer space. But what explains the different colors of the auroras and the shapes? Auroras appear in a variety of colors: pink, red, yellow, green, blue, purple, and even white. The most common of these colors is a greenish-yellow hue, like the one above me. The color of the aurora depends on which gas, oxygen or nitrogen, is being energized by the collisions. Oxygen emits either a greenish-yellow or a red light, while nitrogen generally gives off blue. These colors blend together to produce purples, pinks, white, and other hues. Oxygen and nitrogen also emit ultraviolet light, which is detected by special cameras, but obviously not by the human eye. As well as colors, auroras come in a variety of shapes. Some appear as curtains, while others appear as swirls. Some shoot out of the sky as streaks, while others occur in random shapes. The shapes of the auroras depend on the pattern of the collisions. Auroras appear from 100 to 500 kilometers above the Earth's surface. So, if you were in outer space floating above the North Pole, you would see a thick, glowing patch of color hovering over the Earth, sort of like a crown. As you move farther south, you would notice the patch of light becoming thinner and thinner, quite obvious since Earth's magnetic field is strongest at the poles. But if you were really up there, you'd also die of radiation poisoning. The high-energy particles of the solar wind are hazardous enough to kill human beings, just like nuclear radiation. But don't worry, you're safe here down on Earth, because Earth's magnetic field and the atmosphere provide enough protection. Okay, enough about Earth. Did you know that auroras can be found on other planets too? That's right. Auroras have been observed on planets such as Jupiter, Saturn, and Uranus. Any planet with a magnetic field and an atmosphere is likely to have auroras. You know, the northern lights may not be available for everyone to see, except for those who live in countries near the North Pole, such as Norway, Russia, and even northern Canada. Still, like the world's tallest mountains, longest rivers, and fierce volcanoes, the northern lights is yet another worldly wonder. In fact, it's a wonder that's literally out of this world. Well, that's all the time we have for today. Join me again next time on another expedition. Hope you had fun learning about auroras. See you next time.